So let's start with the new session here. And today we'll be learning about Matplotlib. Okay. So Matplotlib is a Python library that is used for data visualizations. And basically its role is to convert the data that you worked upon in the previous lectures where we used pandas to uh, get some insights or clean the data. So using so that data will be used for a visualization for a pictorial representation. Okay, so like there are many kinds of data visualization types there. For example, line charts, bar charts, scatter plots, histograms, and many more. Okay, okay. So the specialty of Matplotlib is like it's easy as well as it works well with NumPy and Pandas. So when you try to like get some data cleaned, and if you try to get some data cleaned or create some kind of insights using using pandas library, you can also represent that final data as a visualization using matplotlib. Okay, so how do we install and import matplotlib? As you can see on the screen, we have to write a command pip install matplotlib in a terminal, or you can also write that in your notebook file to import it. And to import the library, as there's a import matplotlib.pyplot as plt. Okay, uh, it is like matplotlib a huge library. We are only importing a single component of the matplotlib, which is pyplot, which we'll be using in uh, creating visualizations as plt. So that means like we don't have to like write again and again pyplot or matplotlib.pyplot again and again in the code. We can use this plt. Okay, we just it is just a naming convention. You naming some variable like your name variable. Here we are naming the library as give it a short form so that it's easier in code. Okay, so let's go to the code first. Okay, as you can see, I've already wrote it here, like how to import this library. If you don't have this library or this statement shows some error, you can use this statement in your notebook file like pip install matplotlib. Okay, you just have to give exclamation mark here and then pip install matplotlib as it was in the given in the ppt. Okay, so let's get back to them. Yep. So now, like, what is a basic plot structure? Okay, like we are creating a visualization. Like, so what does it include? What are the things that we need to have while creating a visualization? Okay, first of all, data. Okay, and data should be like not just any random data you take from internet and just starting visualization. Data should be uh, according to the visualization you want. For example, if you want a line chart or bar chart, so you should have like data, like you have some x data that you will be using for x-axis and the data that you will be using for y-axis. It's not like you can just uh, take a random paragraph and try to make a visualization out of it. Okay, figure canvas, like it basically means like what should be a size of the figure. It should be by 8 by 8 or 6 by 6, 3 by, or should be a small figure 3 by 3. So figure canvas should be is a defined as the size of the visualization. Okay, and the title, like what does it figure say? What does it figure says? Okay, like what does it signify? Like if I'm creating a bar chart of what? Okay, or if I create like uh students' heights according to their age. Okay, so I have a title here that is students' height versus age or according to the age. That will be my title, which will be showing like what does it my visualization is trying to show here. Okay, and axis labels. Okay, so axis labels means like what does these x and y axis signify? Okay, until and unless I tell you like x axis is height or y axis is age, you won't be able to know, or you have to like think like what does these axes are saying. Okay, so axis labels are also important. Like x-axis display, you have written height over there, or on y-axis you have written weight or age over there. Okay, legend, legend is something like you can say it is some kind of description in the visualization. Okay, it is optional, like you don't have to give. Okay, okay. So as you can see on the screen, there is an example. Or there, as you can see, there's an example like you have two arrays and we will plot them. Okay, so we will see that in the code. And earlier I was saying about legend, right? Huh. Legend like is something like that describes the data points. Earlier I was using some different kind of definition there. Okay, so legend is something that describe signifies the label points. So are there like if you like put some point like as I was saying earlier, age and height, then that age versus height, that when you will put the point in a graph, you have to like show like this red point belongs to this and this blue point in the graph belongs to this. That's all. You will see in the figure so that you understand it better. Okay. First of all, let me show you just a simple uh, visualization using this example. Okay. So as you can see, I have two lists here, you name X and Y. We will try to plot those X comma Y and see what does we get. Okay. PLT the plot is used for create visualization, and PLT dot show will show you the visualization. It's simple. You can take it as a print statement, but in according to the visualization. Okay. Let's see. See. Now it's just a random graph. Okay, I didn't give it a title, any x label and y label. Okay, so as you can see, it is a simple plot. Okay, here we have just data points. It's just a random graph. Going forward, we will be like putting the entire more details into it. Okay, like what does it y-axis signify, what does x-axis signify, what is the title of the graph. Okay, so let's move to the different type of visualizations. So first visualization we have is a line plot. Okay, which is basically used for showing the trends over time. Okay, like uh, if you are into some or you into some forecasting, or if you ever worked on a time series, okay, or you have seen some graphs on the which signify the sales of any company according to a given time. Okay, so you see that there's a line going up and down and straight going down or up. That signifies the that is where this line plot is basically used. Is basically signifies the like how the trends or how the sales and all the things are going according to the time. Okay, as you can also see in the visualization example in that slide. Okay, so let's say we go to the code and we will create some line plot. Okay, or yeah. Okay, so I'm still taking that these X and Y. Okay, so this time I will use the line function in PLT, give it as a give it a like X and Y array, and this time I'm also using a marker as given an example. Marker basically means it will mark the points with the choice of a symbol, given symbol. Okay, uh, given O here. Okay, which means as you can see here, there are 3 points, right? Like 1, 2, 3, 4, 10. So at these points, you will get a marker so that you can better will be able to understand like where the points. Okay, basically line graph is just connecting dots here and there, and it will show you the trend, like how the things moving. Okay, and plt dot x label is, let's say, time. Okay, time in months, and we will also give plt dot py label, which is sales in units. Units may be like how many units of clothes have been sold over time. Okay, and plt dot title. Okay, which will be sales over time, as it was uh given in the example. Okay, now I will display this graph using plt dot show. Let's see. Plt dot has no attribute line. Okay, let me check what's wrong. Okay, for the line graph we have to use plot only. Okay, I thought we have to like use the line. Okay, my mistake. Okay, so as you can see earlier, we are just this random line looking in there in the graph. This time, we have also given it a title, which is sales over time, sales in units, and time in x-axis. Okay, and we have also put the marker on the points that are used to create this graph. Basically, blue line you are seeing is used to connect these points. Okay, so by connecting these points, we are getting a trend over time, like how many units of sales has been done. Okay, so it is what called a line plot. Okay, and whenever it is just a random small data, whenever you will work on a real life data or for some structured data, you have to keep in mind that mm, you give all these details like x-axis, y, title. Okay, so as to better understand like what does the uh, graph signifies. Okay, and it will be better if you also give marker while plotting them, so that it will be able to mark like what are the where the points they really are. Okay, otherwise you will get like this. Okay, you won't be able to like tell where the points. For example, I can also say like there's 1.5 and around 15 here. Here is also a point, but how can you prove that? Okay, so let's move to next visualization, bar chart. Okay, so bar chart is basically used for comparisons, and it's basically uh, mostly used at the time of using when we used to visualize some categorical values. Okay, so as you can see in example, we have some list called categories which contains the subject names as well as the in that particular subject. Okay, so using these, we are trying to create a bar chart. Okay, it's uh, exactly the same as line chart as you can see in the code. It's just earlier we were using plt.plot, but now we are using plt.bar, which will give us the bar graph. Okay, there are various types of bar graph as you can see in the example, like there's single bar charts or comparatively bar using comparison for these bar charts. Okay, you have like in single visualization, like comparing two bar charts at the same time, or three or four in the count, as much you want. Okay, so let's see how does it work. So I'm taking still same x and y. Here, instead of plot, I will use plt.bar and give it a well, not x. This time I can't use x and y. Sorry. Let's say I'll take the same as example. I will give you the subjects, the list of maths, science, English, and their corresponding marks. Here you will get 90, 89, or 92. Okay. So now I will create a bar chart. T dot bar subjects, comma, marks. Okay. Yeah. Keep one more thing. Keep that in mind while you writing, like plotting the bar chart. You will also get the description like this, where it's showing x array like, height array like. So keep that in mind. The x-axis will come first. Okay. Now, or there was some color in the edge. Let's see. Let me check an example. Yeah, color is equals to orange. You don't have to like remember all these variables. You can also like uh, go through the net, or if you want some any other color, or you just research here and there and get your ideal bar chart. Okay. Now I will give the same arguments again. X label. Here I will get subjects. lt dot y label, which is marks. lt dot title, which will be, let's just say, marks report. Okay. And I will then print print the visualization here. Let's see. So as you can see here, yeah. So as you can see, we have created a bar chart, which is basically signifying the like uh, which is signifying the marks of a subjects. Okay, as you can see, the x-axis have subjects and label, which is called subjects, and y have marks. Okay, I've also put in the label there, and you can see marks report, which we gave as a title. Okay, so let's see it instead of orange, if I want, like, give it something red. Okay, As you can see, I can change the color on whenever I want. Let's just give something so that we can, yeah, yeah. Now you can easily see like we have created some bars which is taking a value as marks, and I can also like work with the width. Let me check. Yeah, let's just say I'm giving it a 0.8 is default. Let's just give 0.5. Let's see. As you can see, like earlier, the width of the bar was uh, more as compared to now. Okay. So you can also change width according to your wish. Okay. Now, if I want 0.5, I will give 0.9. See, the width has increased. Now, again 0.3. So you understand, like you can uh, like tinker around your visualization as much you want. Okay. Now, uh, let's see another visualization, which is scatter plot. Okay, which is basically used to show like what is the relationship or correlation between two variables. Okay, if you remember correlation, we learned it about in previous or last week Sunday's lecture. Like what is a correlation? It signifies like what kind of relationship two variables are having, which means either one increases or one increase then other increases or one increase and then decreases. Okay. So as you can see in the example, we have like create a visualization. Okay. So it basically showing like how these variables are closer to each other or what kind of correlation they enjoy. Okay. So this scatter plot will be very useful when you try to like uh, test your accuracy of your machine learning model. Okay. Because it most of the time we use scatter plot in that it because it beautifully show like how the predicted value are closer to the actual values. Okay, which means like what values you have, what output you have, and what output the model is showing you. Okay, so that's where the scatter plot shines. So we will see that in the code. uh, this time let us say take a different arrays x 2 5 4 7 7 9 10 12 and 15. Okay, that's fine. And same by we will take uh 23 22 34 21 28 and 25. How much we have? 6, and they have 3 5 5 3. Okay, 20 and 19. Okay, so these are the two arrays, and we will create a scatter plot out of them. Plt dot scatter x comma y and pl, and we will write again the label. While we are practicing these visualization, uh, do try to like uh, write these x labels and y label again and again so that you get the practice. Otherwise, you can just like copy paste from one section and then paste it again and again in another code. But you will get a habit of writing it so that you won't forget like what was the text label, how to put the text label. So that keeps that thing like uh, it like feed like stick in your brain. Okay. Mm, plt dot label x label. Let's just say variable one. Okay. plt dot y label variable two. Okay. Or like for like variable x. Okay. Variable y. plt dot title. I will give it plt dot show. Let's see. See, as you can see here, we have variable x and variable y. Okay, we have title and we have some points that we give. Okay, like so. Let me like check. I think there's something wrong here. Yeah, I haven't gave the color. So as you can see, like I didn't give any color here. So it's very hard to this differentiate like which are the variables that belongs to x and which are the variables that belong to y. Okay, so let's see if I give color here. Color red. Okay, so I have another. Let's just say instead of let's do one thing. Uh, I want to like differentiate the points x and y. Okay, so let's see how we do that. Hmm. So basically, what happening in this figure is like as you can see, uh, it is taking x and y value as taken from x and then x from x array and y from y array and then uh forming a pair of x comma y which is used basically used to uh display in a 2D graph. Okay, so that's why we are not getting like different colors. Sorry. Okay, so that's how we create a scatter plot. Okay, now what if I want to like these are some uh, like some random points. Okay, now what happened is I want to do something like let's just say we also have these x and y, right, at the starting that we took. So let's just take them here. X1, y1. Okay. Now we will use again scatter plot. This time we will take x1 comma y1 comma color and this time we will give them green. Okay, let's see now. Okay, so here it is. As you can see, now I'm able to differentiate like what kind of uh, what point belong to x comma x and y, and which point belong to x1 comma y1. Okay, so that's how we can like differentiate between uh, between different variables in scatter plot. Okay, so it will be very useful when you test your model accuracy here, so that you can know like what kind of how much accurate our model that we trained really is. Okay, so we will try to see these plots in some real world data, if time permits. Okay, so here we will also learn about like how to customize these visuals. Okay, so earlier that we using color in the scatter plot and bar chart. There's also something called line style. We will use the line style in the line chart, as well as marker. Marker is this marker. Let me show you the marker. We already used the marker there, the line chart. See, there you can see that like blue dots in the line chart. Na? It is called marker. It is used to mark the data points. As you can see here, I've already gave the marker. Okay, so there are literally many types of visuals customization. As you can see, there's also called grid. We will see grid. Okay, there's color, marker, line size, font size, and various other things like uh they're like I don't remember now, not getting the name, but other than four, there are many things like if you want to like some put it in some kind of interaction mode, so that you can hover at any point, it will pop up the value of that. Okay, so now in this line chart, or let's just scatter plot, since we are in the scatter plot, I will also put plt.grid and put the value true. Okay, so what it will do, it will create a grid. Okay, as you can see here, it created a grid here. So these are the and the color you have already seen, marker you have already seen. We have also some called font size. Font size is basically just uh, these numbers or labels here. They will come in different font. Okay, so let's try something with the real world data. Okay, so for that, let's okay. So what are the best practices? Before that, we should like clear this slide, and then we'll move to real world data. Okay, so what are the best practices? Okay, so like best practice are like you should keep your visualization simple and readable. Okay, the like if you're creating a visualization, it should be simple and readable. Otherwise, it will be like the whole point of creating a visualization is so that the person can easily understand the data. Okay, so if your visualization is not simple or readable, mm, it's no point. Okay, so first most and key foremost thing is like to keep your visualization simple and readable, so that the a naive user, which who does not have the knowledge of the system or data, can sim can still able to easily understand. Okay, and use meaningful labels and titles. Okay, while creating a visualization, you should be able to uh, use meaningful, for ex- like if you are displaying weight versus height, so label should be weights and heights. It should tell like, yeah, these are weights, these are heights. Otherwise, after some time, even you will forget, like, why did I created a visualization in the first place? Okay. And then choose right chart for your data. Not every data is suitable for every visualization. Keep that in mind. So you have to keep the data and just prepare in your mind like what kind of chart will be the best choice for that data that you have. Okay. Or you can experiment with it. You have some kind of data, create bar chart, line chart, scatter, pie chart, whatever you want, and then try to see like whether you are able to understand the data or not. Okay, and avoid too many colors of clutter. Okay, keep the visualization simple and easily readable. Okay, too many colors will uh, means that the visualization will lose its meaning. Okay, it will lose all its meaning if you use too many colors. Okay, try to keep it simple and go with the according to the theme of your presentation, like what kind of theme you are having the presentation, go according to that theme. Okay, and use legends when comparing data sets. Okay, which basically means is like, let me show you in the code. I created this uh, scatter plot. Okay, now how can I know like which data, red point represents which kind of data and green point represents which kind of data. Okay, so here what we have to do is like give a legend. It will give you the uh, show you like what data is represented by what. Okay, let me show you in the code, plt dot legend. Okay, now if I give the legend here, I will have to give some values. Okay, or let's see without values what can it do. Okay, as you can see, you have to use use no article labels founded in a legend called no argument. See, we have to give some variables, otherwise just simply putting legend is not be able to help us. So let's see what can we use there. What should I use? Let's just say if I use this list and give it like data 1, comma data 2. Okay, or I can do this like give the label. Does it have any kind of label? Mm, let's just say give it data 1 or 2. Okay, now we'll give label data 1. I'm doing some experimentation here, so please bear with it. and not given. Let's see. Okay, see. Okay. Mm, To give a legendary visualization, as you can see, now I know that this green scatter plot, green point, gives a reading of different kind of data, and that gives a different kind of data. Okay. So what you have to do here, like while creating a plot, just use label parameter and just write it like what kind of data it is. And then while creating visualization, just put a plt dot legend here. Okay. So giving a legend is one of the best practices there, so that the user can understand like uh, what data is being compared with what. Okay. Now there are two datas, which is data one signifies in red and data two signifies in green. Okay. So that's how legend works. Okay. So now you have assignment. So your assignment is like to create a notebook or Python file using, and you will create all these use all these visualizations and compare the marks. Okay. Okay. So it's like line chart and show the monthly sales data. Okay. So you can just create your own small data, and you have to create a bar chart also using marks like we created in the earlier, sometime earlier, and scatter plot. Okay. Showing the R study versus marks code. So you can just create a small amount of data as you some random data you can do. So this is your assignment. Now let's see if we have some time to work on a real world data. Yeah, we have some time. So let's see, make the most out of it. Now let's just take mm, import pandas as pd, and using this I will take data pd dot read csv, and I will take heart.csv. It is a file that which shows us the parameters like whether, and using these parameters try to predict like whether we have the heart attack or not. Okay. tf dot head. I don't know why it's taking so long. Okay. So it is the first five value of data. We have some columns here. So we will like create some work first scatter plot. Okay. So for that we will take x, which will be df. Let's just say we will take cholesterol. Okay. And we will take as y, which will be uh let's just take resting ECG, which is basically means like at rest what are the like ECG readings, electrocardiograph, which is basically catch a heart rhythm. Okay. And we will try to create a scatter plot out of it. Scatter x comma y. Okay. Now let's see. I will x label. I will take, which is cholesterol. plt dot y label resting ECG. Okay. And plt dot Title. Let's just give it a title. Uh, Cholesterol versus resting ECG. Okay, now PLT dot show. Okay, I think resting. So, like you can also use scatterplot in the categorical way we found it. We just found out. Congratulations. And as you can see, it is a reading. Okay, so like as I was saying earlier, like what are the best practices? Uh, According to me, now I'm seeing the data. The more accurate way to represent the data would be bar chart instead of scatter plot. Am I right? Okay. So as you can see, scatter plot you have like okay, it is not showing any kind of like you cannot find the insights from it. So instead of scatter, let's also try bar. Now I will also give it a color. Let's just say green. Okay. And width. Yeah. 0.5 also okay. See, I thought like bar graph should be able to easily like visualize the data. Now what happened is like I instead of I flipped the x and y axis. So that's how like you have to keep on repeating that to find out what is the best visualization is. Okay. Now y comma x label I put it into y and y I put into x. Let's see. Okay, now it's showing you the most you can draw like most of the insights from this visualization as compared to other two visualizations. Okay, so that's how we have to keep on like repeating ourselves so we can arrive at the best visualization for our data. Okay, so as you can see, the resting ECG will go up to 400 for ST type. Okay, I don't know what ST is. I'm not a medical expert. And for normal, it is 600 up to 600. Is showing as computer data. It can also be 100, 200. Okay, and for LVH, it's also around like 545, 575 or something. Okay, so as you can see here, that's how we can like. There are also many kinds of working happens when it comes to real world data, but it is the most basic. How can we represent uh, real world data in a visualizations? Okay, now maybe there is some library. Sorry. Some kind of visualization type which can better uh, explain these readings as compared to a bar chart. Okay, there may be possibility. Okay. So you have to like find it. For that, you have to like know what kinds many types of visualization. For example, you have learned about line, scatter, and bar. There's also something of pie chart. There's also something from histogram. Okay, so these are the and there are many types of another visualizations. Okay, now so keep that in mind like what kind of visualization uh, what kind of visualization is best for your data. Okay, now you can easily still able to understand like what does figure signify. Okay, so that's it for now. With this visualization I guess you have all understood like how can we signify use real world data in visualizations as well as the best practices. for creating a visualization. Okay, so you have to like understand Matplotlib is a one of the many visualization libraries, and it also like most basic one. Okay, so for that you for understanding other type of visualization libraries, you also need to understand Matplotlib because Matplotlib is a base. Okay, so try to dig deeper in the Matplotlib, and if you have any doubts right now or in the future while practicing these libraries, you can just WhatsApp me. Okay, so any doubts you have right now?
No, sir.
Oh, okay. Okay, then thank you all.
Thank you, sir.